Hello everyone. So, in the last class we have seen about the unit 2. So, in that unit 2 we have completed, in the last class we have completed that static var compensators. So, what is actually the static var compensators? How static var compensator generates reactive power, how static var compensator absorbs reactive power. So, that we have completed in the last class. So, if you go for the types of static var compensators, so in the types of static var compensators, you are going to have saturated reactor and you are having TCR, that is thyristor controlled reactor, and you are having TSC, thyristor switched capacitor, and at the last you are having the combination of these two, that is thyristor controlled reactor, the combination of thyristor controlled reactor and thyristor switched reactor, thyristor switched capacitor we have seen. So, with that we have completed the second unit by having MVR switched capacitors, MVR injection of switched capacitors onto the line to maintain the voltage profile a constant. So, with the help of capacitors, by switching on or off of the capacitors, we can maintain a constant voltage profile. So, here the thyristors are used as a switching devices. So, that we have completed in the second unit. So, till now in the first unit we have completed that there is a load frequency control. So, we are maintaining or we are controlling the power system components or power system equipment to maintain the constant voltage profile. So, by maintaining the load frequency and by maintaining the voltage control. So, by controlling these system parameters, whatever the system parameters are there, that is voltage and frequency. By controlling voltage and frequency, we are maintaining a constant voltage profile, so that we can maintain the parameters of the power system within the limits. That is, we are having the main parameters are voltage and frequency. So, in the first unit, we have maintained the constant frequency. So, in order to have the power quality, a good power quality, and then we have maintained voltage profile a constant. That is, in the second unit we have seen that by controlling the excitation we can control the reactive power. So, by controlling the reactive power we can control or we can maintain the voltage profile a constant. So, that we have seen in the second unit. In the first unit we have maintained the voltage frequency constant, and second unit we have maintained voltage constant. So, by changing the system parameters we are maintaining a constant, and if we coming for the third unit. So, our main subject name is power system operation and control. So, till now we have controlled the parameters of the system, that is frequency and voltage we have controlled parameters. Now, we are coming into the operation of the power system. How we are going to operate the power system with minimum operating cost with maximum load, So, that we are going to see in the third unit. So, that third unit is economic load dispatch. So, how economically you are dispatching the load to the different generating stations or different generating units. So, that is what we are going to learn in the third unit. So, if you go for the syllabus of this third unit, you are having statement of economic dispatch problem. What is actually the economic dispatch problem? How we are going to overcome that economic dispatch problem? So, with the minimum cost of generation. So, that is what we are going to learn in this unit, and then you are having cost of generation. So, what is the cost of the generation? The cost of the generation includes the cost of the fuel which we are using for the generation of the electricity, right. To generate the electricity, we need to have some fuel. So, if we come for the hydel power plants, the fuel cost is almost 0, because the water is fuel for the hydropower plants. So, the water is almost free. So, fuel cost is 0, and then you are having the operating person's salaries and some other expenditure is there. So, that is only the cost of the generation for the hydel power plants. But if you come for the thermal power plants or if you come for the nuclear power plants, the cost for the fuel is very much important here. You need to consider the cost, because the fuel for the thermal power plants as well as for the nuclear power plants, for these power plants you are not having any free of cost, because the coal is a cost, we have to pay for the coal mines. So, in order to get the coal from the coal mines we need to pay for that. So, for that also you need to pay, that means you need to consider that fuel cost in the case of thermal power plants. When you come for the nuclear power plants, so that is also a costlier one, but with a small amount of the nuclear that is what we call uranium. So, with the small amount of the uranium we can get the more amount of the electricity, but the cost is higher if you compare with the thermal power stations, right. So, that is what the cost of the generation, and then you are having incremental cost curve. There is a incremental cost curves, the cost curve between output of a power generated and fuel cost. If you draw the characteristics between that, you are going to get the incremental cost curve, and then you are having coordination equations. That coordination equations is nothing but power loss equations, or sorry, power balance equations. So, that power balance equations with loss and without loss, we are going to calculate the coordination equations, and then with the help of that coordination equations only we are allocating the load to the generating stations, or we are allocating load to the generating units. So, each generating station may have a single unit of generators or number of generators or number of generating units for a single power plant. In a single power station we may have one generator unit, or we may have number of generating units, right. Next, we are having these coordination equations which are going to be calculated with the direct method as well as with lambda iteration method. So, these two methods we are going to see for without loss as well as with loss, by consideration of the power loss and without considering the power loss we are going to see in this third unit. So, if we go for the introduction for the third unit. So, before going to that introduction, what is actually the learning objectives of this third unit? First lecture is to reduce the cost of generation by economic load dispatching. So, we are going to allocate the load to the different generating units or different generating stations in a particular zone. So, if we allocate that, our cost of the generation should be minimized. So, in such a way we are going to reduce the cost of the generation. So, that is what we are going to learn in this lecture, and the next one is to understand the economic scheduling of power system. How we are going to schedule this power system load to the different generating units, that is what we are going to see in this lecture. And the next one is to understand the system constraints. What are the system constraints? How these system constraints will cause for the reduction of the cost, how these system constraints will help to reduce the cost of the generation. So, that we are going to see in this lecture. So, if I go for the introduction to economic operation of power system. So, what is the economic operation of power system? What is actually the power system? The power system which contains generation of electricity, a transmission of electricity, and then after transmission we are going to have distribution. So, you are having generation of electricity, transmission, and then you are having distribution. After the distribution, whatever the generated electricity is there, that is going to be reaches to the consumer. That is the outmost last point where we are going to have consumer. You need to connect between generation as well as the consumer. So, that in between that you are having some power system network, which is a transmission, generation, transmission, distribution, and which is at the distribution stations we are going to have some loads which are consumers, which will consumers will consume the electricity. So, day by day what happens? Nowadays the electricity consumption is going to be increases in everyone's life. The utilization of the electricity is going to be increases because all the equipments which are manufactured to run with an electricity. So, we are going to run each and every equipment with electricity. So, the electricity becomes a part of the everyone's life, but we are not going to maintain the equilibrium between demand and supply. The demand of electricity and supply of electricity is not going to be matched, because as the demand is increases day by day. So, we are not able to match because the demand is increases means we need to install the more amount of the power generating stations. As and when the demand increases, we cannot generate the more amount of the electricity from the existing power plants. We need to increase the generating stations. So, how to increase the generating stations? We need to install the new power plants, depends upon the increasing the demand. So, that we are going to learn in this. So, if I go for the design of a power plant, so the design of a power plant should be incorporate two important aspects. We are going to have two important aspects we have to consider in the design of a power plant. The selection and placing of the necessary power generating equipment should be such a way that it has to result a maximum return from minimum expenditure. So, we have to get the more amount from the minimum expenditure. That means, the power generating station or power generating companies or distribution companies will expect that more amount of the returns from the minimum expenditure. They are expecting the returns from a particular revenue. So, because you are going to generate some revenue from selling the power to the consumers. So, according to that power, whatever the revenue generated for the selling of that power, we are going to minimize our generation cost. According to that, to get some profits, we are going to reduce the cost of the generation by allocating or by utilizing the renewable energy sources, as well as by utilizing the low cost of generation, which will generate the low cost of the generation. That means, we are going to use generators which will generate with less amount. That means, the cost of the generation is going to be less for particular generators. We are going to load that generators maximum. So, that we are going to get maximum returns from the minimum expenditure. So, that is what the power plant or power generation or distribution companies will expect. So, that is the first aspect. The next one, if we go for the operation of the plant should be such as to provide a cheap, reliable and continuous service. What the consumer needs? The continuous service of the electricity is required for the consumers, and it should be cheaper one. So, when you are having any other energy which is cheaper than this, the consumer will go for that. Why he need to use this electricity only? If any other is going to be cheaper, that energy is going to be utilized by the consumers. They are not going to be come for utilization of electricity. So, we need to generate the electricity with cheap and reliable, and it should be a continuous one. We have to provide the continuity of the supply to the consumers, right. So, these are the main two important aspects of a power system, where we are going to install the power generating stations. And you are having the energy demand is day by day increasing. So, the how much energy demand is increasing means the energy demand is increasing 10% per annum, 10% per annum. The electricity or electrical energy is the most popular form of the energy, because it can be transported easily at high efficiency and reasonable cost. At reasonable cost, we can transmit or we can transport the electricity from one location to the other location with high efficiency and reasonable cost. So, that is why the electricity demand is going to be increases, and there we are having. So, as I said that the demand and generation, the supply and demand is not going to be matched. So, the supply and generation or demand, supply or generation and demand, these are not going to be matched together, because the increasing the demand, we need to increase the generating stations. So, that generation is added in steps along with the transmission capacity. We are going to increase the generation as well as the transmission capacity of the transmission lines in steps. According to that increasing is depends upon the demand which is demanded by the consumers. As the demand is increases, we need to increase the generation as well as we need to increase the transmission capacity. So, if we go for the India, so in India electrical power generation is from various sources. If I consider, you are having different sources with non-renewable energy sources and renewable energy sources. So, with all the if I consider all the sources which are available in India, that electrical power generation from various sources, if I consider, that is total is 372.693 gigawatts, that is 372.693 gigawatts as on 31st August 2020. This is what the recent calculations. So, with that recent calculations, I am considering here a total Indian electricity generation scenario. So, how the electricity is going to be generated, with what are the main fuel components, with different, you are having different fuel components with coal, hydel and wind, solar, nuclear, all these things are available. So, with the different generating units with different fuels, how it is going to be generates electricity. That means, if I consider a total generation is 372.693 gigawatts, but out of that, so you are having 53.7 percentage is from coal, the remaining you are having hydel. So, if you go for the hydel power plants, you are having 13.6 and you are having wind power. So, if you go for the wind power, so that wind power is very, so if you come for the wind power, it is only 0.2%, that is 37,940.95 megawatts. So, if you come for the solar power generation is increased, because the cost of the solar power is going to be, the generation of the solar power is going to be increases, the cost is also somewhat less. So, that we are generating the fuel for the solar power plant is 0, only sun we are utilizing the sun energy and we are converting that sun energy into the electricity. So, that is increased in India, that is 9.5%, that is total in the 372.693 gigawatts. In that 372.693 gigawatts, 9.5 percentage is solar. So, that is what here, this is what the solar 35,303.3 megawatts. So, if you go for the nuclear power plants, it is only 1.8 percentage, and there is a gas, with the help of gas we are also generating, right. So, there is from other sources also. So, this is what the total scenario of the electricity generation from various sources in India. So, why I am explaining all these things means, you should understand how much generation is there and how much load to meet. So, depends upon this generation only, you have to generate the electricity and you have to match the demand with the help of this generation. So, that is why I am explaining all these things. These are the very most important for a electrical engineering student should know, right. So, here the integration of you are having 5 electrical grids in India. So, as I already said in the previous classes, that you are having 5 regional grids. So, you need to interconnect these, integration of these 5 electrical grids, that is there are regional grids, these 5 regional grids has to be interconnected, and then that 5 grids has to be interconnected with which will operate with different frequencies. When you are having different frequencies, so you are having the frequency range is from 48.5 to 51.5. So, within that range only you have to operate the power system, right. That is, you are having plus or minus 3%, plus or minus 3% tolerance is there for the Indian frequency. You have to operate the frequency of a particular grid within that particular amount of range, that is 48.5 to 51.5. You need to maintain this, but for different regions you are going to have different frequencies, that is some grid may have 49 hertz and some grid may have 51 hertz and some grid may have 50 hertz frequency. So, all this you need to interconnect. For the interconnection of these 5 electrical grids, which requires a knowledge of various control strategies for proper inter-regional exchange of power. So, why we are going to be interconnection of these regional grid means, you need to consider or you need to generate, you may have some, in some region you may have more amount of the electricity generation, some region you may have less amount of the electricity generation. So, where you are having less amount of the electricity generation, you need to transport that generation from the where you are having more amount of the electricity generated. So, in order to transmit the electricity from one place to other place, we are going for the interconnection of these electrical grids. So, for the interconnection of these electrical grids, we need to have various control strategies and we need to have economic load dispatching problem. So, to overcome that economic load dispatching problem, we need to allocate the generation and load to the particular generating stations where we are going to get less cost of generation. So, in order to get that less cost of generation, we are going to utilize economic load dispatching. So, that we are going to see in the upcoming classes. And then you are having, for a given power system is said to be operating economically. So, if I consider a particular power station, how it is going to be operating economically means, if it satisfies the condition which is minimum operating cost and maximum load demand. If that particular generating station is operated for the maximum load demand and with minimum operating cost, then that particular station is said to be economical operation. It is in operating economically, right. So, if we come for the economic load scheduling, what is actually the first scheduling? Scheduling is means what? Scheduling is a process of allocation of the generation among various operating generator units. So, if I consider a power station which may have different generator units, generator unit is nothing but what? So, if I consider generator unit is nothing but, if I consider the thermal power plant, in thermal power plant you are having a boiler and a turbine and a generator. You are having three main equipments, boiler and turbine and then you are having a generator. So, combination of these three we can consider as a single unit, single generator unit. So, like that you may have different number of generator units in a particular generating station. So, if I schedule the process of allocation of generation depends upon the demand, how we are going to allocate in the different or various generating units, how we are going to allocate that particular amount of the load among the various operating generator units. Let us consider the case that we are having two 500 megawatts generators are there, your load is 900 megawatts. You are having two 500 megawatt generators and you are having 900 megawatts load. How you are allocating these 900 megawatts of load between the two generator units in a particular generating station? How economically you are allocating between these two generating units is the scheduling. So, that is economic scheduling is nothing but you are just allocating between, scheduling is nothing but you are just allocating between the two generator units, that is 450 and 450. We are not considering any economic problem here, but when you come for economic scheduling, it is a cost effective mode of generation allocation among the various plants in a zone or the various generating units in a power plant. You may have various power plants in a particular zone or you may have the various generating units in a particular power plant. So, are you understanding this? Power plant is having generating units and various generating plants also there, that is power stations. How you are going to be generates means how you are going to be allocates the load between the power plants, that is power stations, between the power stations, how you are allocating the load between the power stations with cost effective, or how effectively by reducing the cost, how effectively you are allocating the power, that is load to the generating units which are available in a power plant. So, that is what the two aspects you have to consider here. So, let us consider in a particular zone you are having 10,000 megawatts of load is there. In a particular zone you are having a 10,000 megawatts of load is there. So, that 10,000 megawatts of load, what you have to do is you have to allocate between the 4 power plants are there in that particular zone you are having 4 power plants. In between that 4 power plants you have to allocate this 10,000 megawatts of load. So, 4 power plants means, so without considering the economic scheduling, we are just allocating these 4 power plants, depends upon the 4 power plants are having the same rating. So, each is having 3000 megawatts, that is capable of generation is the maximum generator can generate in that particular generating stations are 3000 megawatts. So, how you are going to allocate this means, just without considering scheduling, that is economic scheduling, just we are considering scheduling of that, then we are just allocating between that 4 generating plants, that is 2500, 2500, and each generating plant is going to be allocated with 2500 megawatts without considering economic operation. But when you come for the economic operation, so out of these 4 generating plants or out of these 4 generating stations, which generator will generate electricity with less cost, we are going to find that by calculating the economic load dispatch problem. By calculating the economic load dispatch problem, we can consider or we can find which generator will generate electricity with less cost. We are going to find that for that particular generator we are going to allocate more amount of the load, that is the maximum capacity we are going to allocate. The maximum capacity of that particular generating plant is 3000 megawatts, we are going to allocate 3000 megawatts for that, the remaining is going to be allocated with the consideration of economic scheduling. So, that is what the economic scheduling. So, if I consider again in that 3000 megawatts we have allocated for one generating plant, and for that generating plants you are going to have allocate within the generating units. That generating plant may have 3 units. Let us consider in this case that generating power station is having 3 generating units. So, between that 3 generating units you have to allocate these 3000 megawatts. How you are going to allocate? With cost effective, that is what the most important here. So, here we are going to allocate that depends upon the less cost of generation, which generating unit, again here I am considering which generating unit will generate with less cost. We are going to allocate that generating unit with more amount of the load. That means, you are having generating units in a particular generating station with installation of generating units that may be installed at the long ago or may be installed recently. The generators which are installed, the generator unit which is installed recently, which is having high efficiency and which will generate power with less cost, and the generator which is installed in the long ago, that is in the 1970s, if you consider, that will have less efficient and which will have more cost of generation. So, you need to allocate the load for that particular generating units with less load. But whereas, if you come for the generating units which are recently installed, which will have high efficiency, which will have less cost of generation. So, for that particular generating units you need to allocate more amount of the load. So, if you come for that particular station, you are having 3000 megawatts of load allocated for that particular generating station. In that particular generating station you are having 3 different generating units, or you consider 4, which are having some 1000 megawatts, right. So, you are having only 3000 megawatts, there are 4 units are there. So, out of that 4 units you need to allocate which generator will generate less, means for that particular generator we are going to allocate the load. So, that process is going to be happens, that I will explain in detail in the upcoming classes with the figures and diagrams I will explain in the upcoming classes, right. As of now, economic scheduling is the cost effective mode of generation allocation among the various power plants in a particular zone. So, this can be also termed as optimal operation, right. There are some system constraints. So, we need to consider these system constraints when we are allocating the load among the generating units or among the generating stations. There is a minimum and maximum limits So, what I am saying is system constraints are nothing but the conditions or the limits on which a system depends are termed as system constraints. So, you are going to have maximum and minimum generation of electricity. So, there must be some minimum generation, there must be some maximum generation. You need to generate in between that only. There are some constraints, you need to consider those constraints. So, for a particular load demand, the cost of the power generation is not fixed, that depends on the system constraints, that depends upon the system constraints. You are having fuel constraints, some different constraints are there. So, if I consider the system constraints, if these system constraints are going to be classified into two types, one is the equality constraint, another one is the inequality constraint. Equality constraints and inequality constraints, there are two types of constraints are there. So, these two constraints we will see in the next class. Okay. So, if I go for the summary of this lecture, so what we have seen is by using economic load scheduling, we can get the low cost of the generation, the low total cost of the generation. By allocating for the generator which will generate with less cost, we can get the total cost of the generation less. In India, we have seen that the electricity generation among various generating sources, we are having the total generation is 372.693 gigawatts, which is the recent one, which is 31st August 2020. For a particular load demand, the total cost of the power generation is depends upon the system constraints. We have seen that there are system constraints minimum and maximum generation. So, for that particular minimum and maximum generation, we need to consider the constraints. By considering the constraints, we have to allocate the load, right. So, with this I am concluding the class, today's class. Thank you everyone, thank you for listening this class.